So, how do you practice solubility? Because it's more than just is it soluble or not. It's more than a yes or no question. It has to do with how much water, what temperature the water's at, and how much stuff you've got, how much solute. So this solubility table, and this is it's a tiny little portion, this thing is pages and pages and pages long, has, 6 compounds, gives their formula, and it gives water temperatures from 0 to 60. So why would it have nothing below 0?
It'd be a solid.
Yeah, because it'd be a solid. And here we are talking about that traditional sense where I said we typically think about a liquid and a solid, and we dissolve the solid into the liquid. And that's what we're talking about. And these are also, you'll note, all listed in grams per 100 grams of water. So the unit on any of those numbers is grams. And that is the number of grams of that substance that can be dissolved in 100 grams of water. Now, a couple things to think about. Are we used to measuring water in grams? No, it's not how we usually do it. How do we usually measure water when we're talking about it? We usually look at volume, and we're using like milliliters or liters. We're using some measure of volume. The important thing to remember is that water is really nice because water has a density of 1. What does that mean? So, water has a density of 1 gram per milliliter, which means 1 milliliter of water has a mass of what? 1 gram. So that only works with water because other substances have different densities. But for water, we can use grams and milliliters pretty interchangeably because 1 gram of water is 1 milliliter of water within a normal range of temperatures. There's some variation when we get up real into the, as we get very close to boiling, that shifts a little bit. At 0, that might shift a little bit, but it doesn't shift so much that we have to consider it for what we're doing. If you were making, like high-grade life or death chemicals, you would have to think about that. At the level of chemistry we're doing, we're not going to worry about it. For our purposes, within the range of temperatures we're working with, 1 milliliter of water has a mass of 1 gram. So, knowing that, let's do the first question together. If you wanted to create a saturated solution of ammonium nitrate at 20 degrees Celsius using 550 milliliters of water, what mass of solute would be required? So the first thing to do is identify where in this table we're going to find the information we need. So we know we're looking at 20 degree water. So we're in this column. And we're looking at ammonium nitrate, which is right there. So we are looking at this number. So for every 100 grams of water that we have, we can dissolve 192 grams of ammonium nitrate. That's a lot of stuff. Ammonium compounds tend to be pretty soluble, and nitrate compounds tend to be pretty soluble, and ammonium nitrate is super soluble. This is good. Where's ammonium nitrate used out in the world? Where? It's fertilizer. Yeah. And the bomb that blew up the Oklahoma City Federal Building was a fertilizer bomb. It was ammonium nitrate. Ammonium nitrate is really soluble, which means plants can uptake that nitrogen, because there's a lot of nitrogen there, because it becomes dissolved in water. So things that are plant nutrients tend to be highly soluble. Okay, that's a sidebar. So we're going to use 550 milliliters of water. What mass of solute do we need? Well, we can do this as a factor label. So what's our given here? 550 milliliters of water. So 550 milliliters of good old H2O. And it's helpful because it helps you to remember that this is a special case for water. It's helpful to say, okay, well, 1 milliliter of water is the same as 1 gram of water. Because now we're going to go into that next thing is grams of solute per 100 grams of water. So we know we need grams of water on the bottom. And the solute values are given in 100 grams of water. So for every 100 grams of water, what mass of ammonium nitrate can we dissolve? 192 grams of ammonium nitrate. So that'd be NH4NO3. What units are we going to end up in here? Grams of ammonium nitrate. Is that what we want? Yeah. The other thing that I find really helpful, let me get rid of my crossing outs here. I tend to do this for myself so that I don't do dumb stuff. I write 100 grams of H2O at 20C. Because that reminds me that this is a value that's going to change. This is a different number if it's at 10 degrees Celsius or 30 degrees Celsius. How much different? Holy moly, 10 degrees warmer, look at how much more we can dissolve. You know, so it's significant. Okay, get a raw number. We've got a raw number. We're still working. 1,056 grams of ammonium nitrate. Now, of course, we have a small, we can have 2 sig figs. Oh, no, we can have 4 sig figs. Okay, we can have 4. I was just sloppy when I wrote my given initially. So if you had 550 milliliters of water at 20 degrees, you could expect to dissolve 1,056 grams of ammonium nitrate in it. So let me ask you the other question. If I had 550 milliliters of water with 1,000 grams of ammonium nitrate dissolved in it, is that saturated, unsaturated, or supersaturated? It's unsaturated, because you can still add more solute. Okay? So what I'd like to do is, do you feel relatively comfortable with doing these? So a couple different ways that these problems can be done. One, we say, okay, here's how much water you have, how much solute can you dissolve in it? But there are a few other permutations, so I want to look at least one of those with you. Okay, so here's one of the other ones. Is a solution that's composed of 2.5 liters of water at 50 mixed with 850 grams of ammonium phosphate, saturated, unsaturated, or supersaturated. So what we're saying is this is a solution that, you know, from the evidence in this statement, it's not chunky, it doesn't have stuff in the bottom that's undissolved, it's just 2.5 liters of water, 850 grams of ammonium phosphate. So what do we need to do? It looks like we have 2 givens initially, doesn't it? This is one of those problems where you're going to find a value and compare it to what you were given. So what should you start your factor label with here?
2.5 liters of water.
You want to start with the 2.5 liters of water. You want to figure out how much solute can be dissolved by that. So we're going to get a number, we're going to get a value for solute that can be dissolved, and then we're going to compare it to the 850 grams we've got. So to start this out, we would take the 2.5 liters of water. You want to do your volume mass conversion. If we go straight into liters of water, 1 liter of water would be how many grams? 1/10 to the third, yeah. 1 milliliter is 1 gram. 1 liter is 1,000 milliliters. So this is 10 to the third grams, or you can say 1,000, it doesn't matter. And for every 100 grams of water, how much of that solute, the ammonium phosphate, can we dissolve at 50? So 37.7. Look at the difference in solubility there. NH4, 3, PO4. Okay. Get a raw number. Okay. When you have your raw number, you can look up here and see if it compares favorably. 943 grams of ammonium phosphate. What does that mean? Because that's not our answer. Our answer is going to be saturated, unsaturated, or supersaturated. What is that number telling us? It has room to dissolve more ammonium phosphate. So we could put in another, 90 grams of ammonium phosphate and expect to get it to dissolve pretty well. So this is unsaturated. So your answer for this would be unsaturated. Questions? Okay. I'm going to cut you loose to work on the practice sheet. This will be a homework grade, even though we've done 2 together. So keep working and I'll keep circulating.